started here. Welcome, I'm Andy Johnson with Defenders of Wildlife, and we're very pleased that we have Dr. Ed Gregr here to speak to us today. First, I'll just cover a couple of housekeeping items. We do have the chat open, but we'd prefer to use the Q&A function for questions. Heather will be sharing probably some links and other things as we go along. So keep your eye on the chat. But if you have questions as we go along, please enter them in the Q&A function. We'll collect and sort the questions and ask them at the end of Ed's presentation. And thanks for joining us again. We're coming to the end of our 20th anniversary of Sea Otter Awareness Week. Just tomorrow is the final day, and it's been a lot of fun. We have had a lot of scheduled presentations and been out to a couple of the otter spotting stations, and a lot of organizations have been doing social media, getting content about sea otters and their role in nearshore environments out there. And I think Sea Otter Awareness Week continues to be a great forum for sharing information about sea otters and engaging the public. So I guess we'll keep doing it. And on this particular presentation, we're collaborating with Sea Otter Savvy to bring the webinar to you. And this is a We Were Here event. So I'm going to turn it over to Heather to tell you about We Were Here. And I'll come back in a minute.
Yeah, thank you so much, Andy. Hi, everyone. Yes, if you've been tuning in, you've probably heard me talk a lot about this already, but I'm always going to add a little bit more. So my name is Heather Barrett. I'm the Science Communication Director for Sea Otter Savvy. And I wanted to note that this week is also highlighting Sea Otter Savvy's We Were Here Sea Otter program. We are educating communities and stakeholders that are missing sea otters. And we're also offering a survey for community involvement. So the Southern Sea Otter Range is currently from around Pigeon Point in the north, it's near Año Nuevo State Park, to Gaviota State Park, which is in the south, and you can see that on the map there. And this is just a small segment of their historical range. So sea otters did once inhabit all along the Pacific coast. They are ecologically as well as culturally significant, and there's increasing discussion regarding possible reintroduction to historical habitats. So to move forward, government agencies and sea otter research community, we really need to hear from you. We're engaging with stakeholders and want your perspectives. So if you're wondering an action item that you can do today, please take the Sea Otter survey, share your thoughts on possible reintroduction. We want the pros, the cons, your concerns, your questions, your ideas. Your voice matters. So the links in the website and the survey are all going to be made available to you in the comment section. I'll add those again. And then the last thing I wanted to remind everyone is that Sea Otter Awareness Week is not done yet. We do have a couple more events that I want to make sure we get a plug in for. We want to remind you that we're going to have happy hour with the sea otter biologist. It's going to be this evening at 5:30 p.m. and it's on Instagram Live. So that just make sure you follow us at Sea Otter Savvy. Go to Instagram and you will pop up when we go live, and you can click there and be able to ask questions to Colleen Young. And then tomorrow at noon, there's another We Were Here for last programming with Sea Otters and Eelgrass with the Marine Conservation Institute, and they're going to be hosting Dr. Erin Foster. So you'll learn more about recovering sea otter populations and how they can increase eelgrass genetic diversity. But with that, I'm going to pass it back to Andy.
Great, thanks, Heather. It's my pleasure now to introduce Dr. Ed Gregr. Ed is a principal with SciTech Environmental Consulting in Vancouver. He got his bachelor's degree in computer science from Simon Fraser University and his master's degree in zoology from the University of British Columbia. In 2016, Ed earned his PhD at the Institute of Resources, Environment and Sustainability at UBC and became an adjunct professor at the Institute in 2017. Ed is an expert in field research design and sampling and project management, considers himself a systems ecologist, investigating the intersection of ecosystem services, risk, and human values. He's interested in using spatial models to inform ecosystem-based management and to have those models perceived as credible, relevant, and legitimate to managers and stakeholders. And this is the part I like in particular. He pursues opportunities to build these models in contentious and complex social ecological contexts. And that's what we have here, I think. So Ed is going to talk to us today about valuing the costs and benefits of sea otter recovery. Take it away, Ed. Thanks.
All right. Well, thank you very much, Andy. Everybody hear me okay? Or someone? Am I coming through, Andy?
Yes.
Sounds great.
Right. Okay. All right. And screen is up.
Looks great.
All right. I'm just going to do that. All right, terrific. Oh, well, hello, everybody. Good afternoon. It's a pleasure to be here. I don't get out much these days, so this is as close as it's been the last few years. So I'm really happy to be here. Thanks to Andy for inviting me, and to the Defenders for hosting my talk. So I'm here to talk to you about the modeling that we've done really to assess the trade-offs in part of the sea otter range up here in Canada, where they were first introduced, and where they've reached carrying capacity in large parts, in a part of their range. I'd like to start by just acknowledging the very large team that was behind this work that we called the BC Coastal Ecosystem Services Project. Without all these folks collecting data all the way from oceanographic to oceanographic data all the way through to the biology, this project wouldn't have happened. Also wouldn't have happened without the funders. So lots of people involved, and I am really the glue that, as a modeler, that brings all these pieces together. And in that little box, you can see where we did most of our work. My talk's going to be focused on stuff off of Vancouver Island, and I'll zoom you in to there in just a minute. I would like to start just to sort of give you guys a flavor of what I think models are, because I'm not sure how everybody's perception of these things are. And in fact, models are very ubiquitous. We use them throughout science, and in fact, they underpin all of human cognition. And almost everything is a model, I would argue. And I can argue about that later. I just wanted to give you some examples to sort of bring everybody up to speed a little bit. This is a very simple regression model from statistics relating to variables. Presumably you've all seen something similar to that. Just one of many types of models. We also have models that describe organisms or places, just to sort of get an idea of what things look like. There's also models that we use more sort of geographically. This is an image of plankton concentrations off the coast of Vancouver Island. And often, the reason I'm showing you this image is because often we use such images as data in subsequent models. But this picture that shows chlorophyll concentrations is actually the product of a model that has to translate reflectance collected by satellites into these measures of chlorophyll that we use. So even things that we consider in science as data and use as data are often underpinned by models that have to translate it from the sensors to the data that we use. And of course, perhaps top of mind model for lots of people these days are the global climate change models. I want to make 2 points with about these models that are kind of generic about all models that we use in science. The first is that the climate change models are global models. So their objective is to fit historic data around global average temperature and project that into the future to see how things are changing and to look at the causes of any potential changes that are observed. The fact that they're global models, that's their objective, means that they're not very well resolved, because to map the whole globe, we don't really have the processing power to do that at kilometer scale or even tens of kilometers. These models tend to be resolved at hundreds of kilometers. And by that, I mean it divides the world up into pixels or grid cells that are 100 or 200 kilometers in size. That means that while these models are good at global averages or even hemispherical sort of data, they do not tell you what's happening regionally in your backyard, because across that 200-meter pixel, it's just a single value. And we know that temperature and weather changes at a much finer resolution than that. So that's one of the trade-offs that you have to do in modeling, is this spatial extents, the size of your area, versus the resolution that you want to work at for your particular study. And so that this is meant to emphasize the importance that models, while everywhere, every model works best when it's targeted to answer a specific question. The other point that I want to make quickly is that from the graph below, you can see that there's lots of variability in the data. There's lots of variability in the weather. So the fact that the climate doesn't warm up necessarily every year or year over year, that there is some variability in that, is a function of the natural variability that is not necessarily represented in the model or can't be represented at the scale that it's built. The best way to think about this is that's why we have climate models, but we don't use those for weather forecasting, right? Weather models are completely different, and they certainly can't do a long time series. Weather models are resolved quite differently. They work on the order of hours, days, and weeks. So that's meant to illustrate that models are very purpose-built, and no one model will be able to answer all your questions. So switching to ecosystem models, which is where I spend most of my time. This is an example, a very good, actually, example of a particular ecosystem, the Antarctic ecosystem, because it has penguins, and it's a good model because it doesn't have polar bears. This is an approach that this is a simplified version showing the species that are in that particular ecosystem. And it's, one way to simplify a system if that's what you're interested in the species in the system. The reason we need to simplify models is because the ecosystem is a very complex thing. This image shows the conceptual interaction between all the pieces of the ecosystem in Southeast Alaska. And conceptually, we know that, stuff that goes on in the ocean, the physics that drives things, the winds and the upwelling and those sorts of things drive food webs that feed everything that's in the ocean. The ocean's responsible for producing the phytoplankton. That feeds the forage fish, which feeds higher trophic levels. We also know that there are these teleconnections between the seascape and the landscape, which supports our salmon. And we certainly know that people benefit from these ecosystems in myriad ways. We just don't know how to quantify a model of this complexity because there is just so much going on at so many different scales. So while we can understand things conceptually, if we want to look at trade-offs and inform management decisions, we need to simplify things and bring them down to a level of complexity that we can parameterize, that's tractable, but at the same time is still relevant to the people that are making the decisions. So that's one of the biggest challenges perhaps for ecosystem models, is finding the right complexity, the right resolution to answer the question at hand. So the question at hand for us was about sea otters, and I'm sure most of you are familiar with the history of sea otters, so I'm just going to go through this quite quickly. To bring it to a local context in BC, we started hunting sea otters in 1750. This was just a couple years after Vitus Bering made his epic journey from Kamchatka over there on the left, over to along the Aleutian chain and out to North America. He came back with sea otter pelts, and they realized that they were warm, and the hunt began in earnest just a couple years later. Sea otter pelts were really prized and valuable for all obvious reasons, and the hunt globalized very quickly. And almost as quickly as it globalized, we drove them to economic extinction, not real extinction, fortunately, causing or leading to protection of sea otters and a few remnant populations, particularly up in Alaska. And this story is about the translocations that were undertaken from these two sites, Prince William Sound and Chitka Island, over to other parts of the coast, particularly that central dot in Cayucet Sound, which was the sort of focal point of our work. Now, the translocation in BC was really successful. They arrived in, as I said, in the late 60s, early 70s, over 3 translocations. They dropped 100 animals off here. And at this point, I think our population is pushing over 5,000 animals. They were successful in part because they eat a lot, and that eating supports not only their insulation, but their reproduction. And in BC, at least, during the early part of their expansion, the population was doubling every 5 years. And so as a result, Off the coast of British Columbia here, we have a sea otter population that's doing very, very well, that continues to expand and can be seen as, pretty good example of rewilding and a conservation success story. The effects on the ecosystem are as dramatic as sea otter reproductive rates. As many of you know, I'm sure, sea otters have an effect on sea urchins. So when there are lots of sea otters, sea urchin populations tend to be smaller. Urchins are smaller, they're more cryptic, hidden in places. And because sea urchins prey on kelp, kelp is allowed to expand throughout its environment and create larger kelp forests. When we remove the sea otters, sea urchin populations increase and have a negative effect on the kelp forest, leading, as you've probably all seen, to urchin barrens that look a lot like this. And in the absence of sea otters, who eat a lot of urchins and other invertebrates, many invertebrate populations, maybe all invertebrate populations in the Pacific Northwest, became hyperabundant and very large. And about the same time as otters were reintroduced, interestingly enough, in the 70s or so, at least in BC, we developed fisheries on these hyperabundant and extra large invertebrates, in not just urchins, but also abalone, geoducks, and Dungeness crab, of course. All these species were larger and much more abundant in the absence of otters, allowing really these fisheries to become established. And so the question for us as part of our study was the contrast between these two situations, right? These two contexts where you have otters present, that's seen as a restoration of natural ecosystems, quite rightly. And sea otters are also valued just for the fact that they're a recovered species, so they have an existence value. And the fact that they're so cute makes them really attractive to the tourist industry. And in contrast, of course, there's a rapid decline in invertebrates, economic loss for coastal communities, or at least coastal fishers, and some cultural and subsistence loss for the communities. So this has been portrayed, at least in BC, as a black and white conflict. We either have otters, and we don't have recreational invertebrate fisheries, or we have the fisheries, and the otters are a hindrance to that. Our study, BC Coastal Ecosystems Services Project, was interested in whether this is a complete picture of the sea otter invertebrate trade-off, whether that was all there was to it, otters versus commercial fisheries. And to get at that, we wanted to see how local field data, we had a big field program, we wanted to see how those field data translate into regional effects of sea otter and kelp recovery. And the way to do that is to combine those field data with models to try and capture how the pieces of the system interact. So here's Vancouver Island. The green area is the range of sea otters at the time we did our study. And we picked 3 areas along the island that we sampled in 3 different locations. Cayucet Sound is where they were introduced, so that's had otter occupancy over 20 years, and that area can be considered to be at carrying capacity. The population growth there has pretty much stopped. We also collected some data in Clayoquot Sound, which was a transitional area, and so showed the greatest increase year over year, the greatest rate of increase for sea otters. And in Barkley Sound, which at the time and almost still today does not have any otters in it, so it can be considered an otter absent area. The work that I'm going to talk about will focus mainly on the 2 extremes. You'll hear me talk about otter absent and otter present areas. So those are the 2 areas where those data came from, was Barkley Sound and Cayucet. So I want to quickly show you some of the results from our field work that we then rolled into the model. This is the biomass of invertebrates, fishes, grazers, and other critters, ordered from bottom to top in terms of well, it is, except for the bottom panel in terms of trophic level. But anyway, starting at the bottom panel, you can see what I just introduced, the conflict where large grazers such as urchins, abalone, and turban snails and others are really abundant when otters are absent. That's the first column. But shortly after sea otter occupancy, their abundance drops quite quickly. In contrast, kelp forests, the panel above, and all the species that rely on the kelp forest, going up from that, the grazers, the crustaceans, and fishes, after a longer period of otter occupancy, become much, much more abundant than they were during an otter absent area. So this illustrates part of that shift from an otter absent to an otter present situation. Just one more slide on the data to go up a few more trophic levels. These are a couple commercially and culturally important species, cod and copper rockfish. The blue bars show the catch per unit effort, which is a proxy for abundance in otter absent areas, and the green bars show abundance in otter presence areas. And you can see that there is quite a stark difference in the abundance of these particular species between those two areas. Just a quick note that the reason there are two bars there is that this sort of study needed to be corrected for human fishing effort, because human fishing can also deplete the abundance of target species. And so the point is that despite human fishing, this trend is strong and persistent between the two areas. Looking at copper rockfish and also another type of common rockfish and their diets, we caught a bunch of fish and sacrificed them and dug through their stomachs to see what they were eating. And in the otter present areas, the green dots and surrounded by that rectangle, the trophic level that these fish were feeding on was significantly higher than the otter absent areas. This means that there is a higher diversity of higher trophic level species that are available to these fish, and probably leads to higher growth rates and obviously higher abundance of these species. So that's all a contribution of the kelp forest. And there are two pathways that are involved there. First being just the primary production that extra that those plants put in the water, feeding the food web from the bottom. And the second thing is the habitat that the kelp forests themselves provide for all the critters that live on or around them through various mechanisms. Okay, so those are the data that we collected. And just to sort of summarize our findings, sea otters increase the kelp forest size by quite a bit, and also moving it deeper. The catchability or abundance of reef fish and trophic levels, as I just described, allowing us to infer that biodiversity was increased. And the juvenile rockfish abundance, that's a reflection of the habitat that's provided by kelp forests, because it helps settlement, recruitment, and protection from predation for juvenile rockfish. So their abundance and diversity went way up within the kelp forests. So how do we translate that to sort of ecosystem effects at the regional scale? Well, modeling is a hierarchical exercise. At least ecosystem modeling is. Well, I might be able to generalize that. Point being that for what we did and what you want to do if you want to look at trade-offs in different ecosystems, you start down here at the bottom with field studies, and those provide data. You take those data, you build your ecosystem models, which are often trophically based. So it's who's eating who and how much. That lets you estimate the abundance of the species of interest. Then if you know something about where those animals like to live, you can build habitat models, which combined with the abundance lets you get at the distribution of your species of interest. And then if you figure out what value or what services those species provide to human communities, you can come up with what we call ecosystem service models and estimate the services and their distribution. And if you talk to people more, this is a really hard part that we can talk about a bit later, actually getting to the benefits that individuals, communities, and jurisdictions get from ecosystems, then you can actually do meaningful trade-offs and inform management decisions at the scale of benefits to people. That's really hard because benefits are difficult to quantify, they change. And you ask 6 fishermen what they prefer, you probably get 6 different answers. Same with ecologists. So that's the really tough part in terms of the hierarchy. We're getting pretty good at getting to the ecosystem services piece, though. Okay, so I'm going to walk you up through this hierarchy to the point of services and talk a little bit about benefits in the context of our Sea Otter study. We used something called EcoPath with EcoSim, which is kind of the, it's been around for, I think, 30-ish years by now. There've been hundreds of models built with EcoPath around the globe. And every good EcoPath model starts with a food web, which you see a picture of here below. I know those names are a little hard to read. They're not super important. The point is that you need a food web with the species of interest, and the arcs here represent the trophic interactions. It's basically who's eating who. The size of the dots represents the biomass that you have in your area of interest. So in that little map on the right, I've got a rectangle describing our study area, which included intertidal waters down to 40 meters depth, kind of the foraging range of sea otters. And we bounded it so that it included both the area where sea otters were carrying capacity up in Cayucot, as well as where they were still absent down at the bottom right in Barkley Sound. This might be the hardest part of building these trophic models, is that for that area, you have to estimate the biomass of each of those species that you've put in your food web. And you get that, well, we had a lot of field data to do that with, but you can also use fisheries data for species of commercial interest. And often we take parameters from a global database of like species that have been compiled by other researchers. So that's a bit of a source of uncertainty, but you put those data into EcoPath, and the first step is to do what's called balancing the model, which is basically an energetics exercise. With all these linkages in the food web, energy in kind of has to equal energy out. And so the whole balancing thing just makes sure that there's enough energy for everybody in the model as defined by the biomass of what everybody eats. Okay. If I've made any sense and you've been, you kind of, and you can read this, you'll see that sea otters over here have a very small dot, which means that for this particular image that I'm showing you, sea otters were very, very rare. So this model would be parameterized, or this network is showing the biomasses, the relative biomasses in a sea otter absent context. That's why there's lots of urchins and gooey ducks in it. Okay, so I think I have, yeah, so the question is who to include. This is going back to the question, what do you need to include in your model and answer your question? That's and how much is there? So I just went through those 2 pieces. So now we have a food web. We know who eats who. We've got it balanced. And so what you do with your EcoPath model is you run it through time and see how the interactions change. What you see here is the proportional change in the biomass. So things that are down around 0 do not change year over year. And every tick up that axis is a doubling of the biomass. So what we saw over time was that sea otters increased from the few hundred that were dropped off in the 1970s to just over 75 times that is what the estimated capacity for the West Coast is. And that increase corresponds to what we expect to happen with sea otters in the area that I showed you. Similarly, you can see kelp increasing by around 10% or so. This is different than the number that I showed you earlier, which was like 20 times wider and 4 times deeper, because remember, this is averaged over that whole study area that I just showed you. So it excludes beaches and other areas where that is not kelp habitat. So this increase is on average across that whole study area. And the same is true for all the other species. And all the other species that I showed you in the food web are down here in that thick bar at the bottom because their increases are not nearly as dramatic as for sea otters. A key part of parameterizing this was something called space for time substitution. Remember, I made a big deal of Barkley Sound being an otter absent area. So it can actually serve as a proxy for the time before otters were introduced and reoccupied the area. Similarly, the data from Cayucit can be used as a proxy, as a substitute really for the time when sea otters will reach carrying capacity in the region, which we expect to be some decades from now. So that's how the data from those two regions were used to test, to fit and test these curves. I actually used them to test them like it was fit using the balancing data that I described earlier. There's a whole bunch of other parameters and assumptions that you need to make, but the way that you validate these particular simulation models is with the available data. And so we had those two endpoints, which were really necessary in terms of making these curves realistic, defensible, that sort of thing. Okay, so that's how the system changed over time, and that's how, well, a very quick overview of how we actually built the model. So let's just have a quick look at the actual transformation that took place. This y-axis is the same, but looks a little different than the one on the previous graph, just been changed to percent, altered so it shows percent change instead of relative biomass. But so in this case, 200 would be a doubling of the biomass from the baseline, or the change in lingcod biomass from an otter absent to an otter present state. And you can see that for all the other critters in the model, their relative changes are shown, as I said, from otter absence to otter presence, to otters being at carrying capacity. And we see everything that we've been sort of talking about. We see the fish go up. We also see all the small invertebrates that rely on the kelp going up. And we see the loss of the commercial invertebrates, primarily the urchins and the crab. The shellfish seem to have a little bit more refuge from sea otter predation, so they go down as well, but not as much. In the little insert, you can see that the kelp increased. Giant kelp increased the most, 14 times more giant kelp in our ecosystem. Only about a doubling, a little less than a doubling of the bull kelp, which tends to be in more exposed waters and a little bit more sheltered from urchin predation. So that could be why that was. And we had another kelp group that was up about 5 times more. On the whole, if you add up all the biomass, 37% more biomass in an otter present state. That is a lot of food and animals in the water, a lot more food and animals in the water. So what could the possible benefits of all that extra biomass in the water be? And that's where we turn to ecosystem services. We looked at 4 of these. Obviously, the invertebrate fisheries were a big part of this study. And we did some work looking to estimate the tourism value of sea otters, so we could compare that. Then we looked at two services that were a direct product of kelp production. The first being the supplemented catch, which is really that question about the 37% increase in biomass. A bunch of it will stay in the food web, and it will feed the food web bottom up, so that you will end up with more lingcod, more rockfish, more halibut. So we estimated how much that could be. And we also estimated how much of that kelp, which, as you know, gets ripped up during storms and transported away from the coast, a significant chunk of it tends to sink. If it sinks deep enough, then there's a carbon sequestration benefit to that. So these are the 4 ecosystem services that we looked at in our study. We chose services that could be monetized, which is an important part of management decisions, and it's the straightforward way to do trade-off analysis. Those management or those activities trying to do trade-offs and make management decisions or choose between management decisions are really complicated if you don't have things that can be turned into money, unfortunately. It's just we need to include those other things, but it becomes very complicated because benefits and people and differences and stuff like that. Anyway, so that's why we chose monetized services, because it was a lot easier than getting into the social science of benefits. And just to take you straight to the results here, on the whole, we got about $40 million more a year based on our estimates out of the system with sea otters than it has in it without. The commercial catch losses were on the order of $7 million. We expected that once otters recolonize the whole coast, that finfish would yield $9 million more than they yield now. So even on that trade-off, there seems to be a win for the commercial fisheries, albeit different ones. Carbon sequestration had contributed something, and tourism seemed to be the biggest winner here, which has some assumptions and some that I'll talk about in a minute. Now, if anybody shows you a model and just gives you point estimates like this, you really need to be skeptical, because models, as I've been saying, have a lot of assumptions in them. There's a lot of uncertainties. What you really want is some range of values that look maybe not like this, but something like this, to try and estimate the uncertainty, uncertainties really that are in these sorts of models. I don't think I want to elaborate on this. If you're interested in what goes into these, I'm happy to tell you. It does include, though, uncertainties around the ecosystem model itself. I forgot to mention what those error bars were. If you noticed them in that comparison of the species biomasses before and after otters. And it also includes, most of the uncertainty, though, is driven in the translation, is driven by the translation from those biomasses into these dollar values, because these dollar values are projecting into the future, and we all know how hard that is to do. So that's why they're big. But even still, even if the lines on the violin plots, they're called, show the median value, the thick one, and also the 25th and 75th quartile of those distributions. And even looking then at the bottom quartiles of the benefits and the highest quartile of the loss, it's still going to be a more valuable system, at least in terms of these particular variables that we're looking at. A few caveats on top of the ones that I've already mentioned. All losses are not captured, in particular the value of subsistence to coastal communities. We did not do that. And in terms of the benefits, they're there, but they may not be realized. People may not choose to engage in tourism, and they may also not be equally distributed, because some people may still be able to catch things deeper. Other people, for example, or there's many other ways to get it to have unequal distribution of benefits. One thing I want to expand on a little bit more here, just trying to check as to how I'm doing with time. Well, yeah, okay. I'll try and be quick. Local management is being seen as more and more important of these resources, because it helps with perhaps equity, and also helps you sort of maximize really your resource base if it's heterogeneous, right? So we wanted to look at a couple other management options, and I'll show you how we did that here quickly and the implications of that. These are the two scenarios that I've been talking about: the no otters and otters at carrying capacity one, showing the areas, the main sounds on the coast. We wanted to see what would happen if resources were protected in the middle of that range. There happens to be very lucrative gooey duck and crab harvesting grounds in the red area. So we wondered how management, or how the results would change if we excluded otters from that area or protected the resources in that area, kind of the same thing. We also wanted to look at local exclusion around coastal communities, because the subsistence question is really important in Canada and in British Columbia in particular these days, because a lot of the communities are very remote up there. It's half a day to go to the grocery store. And so people are really quite reliant on local resources, particularly shallow invertebrates. Okay. Now, once you start breaking things up in space like this and looking across more than one management opportunities, the data get really big. You've just added 2 dimensions, and it gets quite hard to look at simply. So I'm going to, before I do that, I'm going to tell you, like I told you at the beginning, that to do this, we had to build some habitat suitability models, right? Because now we're going from abundance to distribution. And so we built suitability models for this area of the coast for sea otters and a bunch of the species of interest. Okay, so I'm just going to show you one part of this, which is the invertebrate catch loss to the fisheries. Okay, and what we're going to do is we're going to use the coastal communities, and we're going to call that the close area. Okay, and the rest of the blue area, we're going to call that the distant area. The assumption being that close areas you can harvest with a little turnstiller 14-foot boat, turn-tiller 14-foot boat, whereas to go beyond 10 kilometers from the communities, you need a more substantial vessel, more capital. So it's kind of the kind of a proxy for recreational or subsistence fisheries close to communities versus commercial fisheries further away. The results that you see here are exactly what you saw before this. The black bar shows the roughly $7 million loss. Okay, but here it's partitioned between distant and close. So this can be seen as the loss to coastal communities, while this would be the loss to commercial fisheries, if you like, just coarsely put. And now if we look at what happens when we do, when we protect some areas, some resources from the sea otters, obviously we lose less on the whole, right? Both the little black bubbles are higher up, so we've lost less. And the regional, and that's reflected in these as well. The regional exclusion, there's more invertebrates in the regions where they're excluded, and there's still a bigger loss in the distance to the distant areas. But the local exclusion, though, is what's really interesting, because there's almost no loss to coastal communities in that case. And much of the loss is borne by the more distant areas that you need better access to. And this distinction between fisheries and subsistence is really important in BC, because a lot of the fisheries have been consolidated in Canada now. The people who are doing the fishing for most of these species don't live in the coastal communities. They come from the major urban centers. And so looking at things this way is a way to start addressing local equity issues. And in this example, you can imagine we're not only talking about the equity, for example, between close communities and distant fisheries, but also across regions. One could do the same sort of thing, thinking about whether the regions are being equitably treated with a particular management option. Okay, and as I've been harping on, this is a good, important subsistence question, and also touches on recreational harvest. So just to conclude then, because I know I've taken up too much time, ecosystems worth more with otters in it. And by being deliberate in the modeling and exploring different ways of building the models, things can be valued more holistically, instead of just looking at a trade-off between sea otters and fisheries. Important to recognize that it's only a model, so you can't fit everything in it. But I think there's a strong case to be made that local management, nevertheless, a strong case can be made that local management could support more equitable, effective resource allocation. And I'm done. Thank you so much for your patience.
That's great. Thanks, Ed. Some pretty amazing stuff there. We'll maybe get at a couple of questions. So let me just resize this. And see if you could stop your share, then I think we'll reappear.
Oh, I remember how to do that. I remember how to do that. All right, there we go.
There he is. Okay. And yeah, let's see. A couple of questions. First, how did you test how well the ecosystem model worked? I mean, how sure are you that that what your results were would be plausible in a real world scenario?
Yeah. Oh, well, that's really important, right? The ecosystem model, when you build a food web like that, it's the more things you add to it, the more fixed it becomes. So by having all those species in there, and then getting it to balance, getting the energetics to actually correspond, is a good sign in and of itself. But to make sure that we were capturing all the potential ways that it could be parameterized, we used what's called a Monte Carlo simulation. And we picked, what that means is that we ran the model 1,000 times with different potential parameters. We moved all the parameters around as much as we could to maintain a balanced model, to convince ourselves that the parameters that we were using were reasonable. And those were the error bars that I forgot to mention when I was showing you the overall results between the two systems.
Got it. Let's see. A couple things came in through the chat. One person wanted to understand the difference between commercial catch and supplemental catch, and do the fisheries have to change what they harvest?
Okay, so that's a bit of a two-parter, I guess. In the presentation, I was talking about the commercial catch and the impacts on the commercial catch. I really meant just the invertebrate fisheries, the fisheries that we're targeting, clams, gooey ducks, crab, and urchins. So those are the fisheries that we quantified the losses for. The fisheries for the supplemented catch were the finfish fisheries, and they did not directly enter the model. What we actually did was estimate how much of that 37% biomass would make it up the trophic levels. There's 3 trophic levels to go from primary production up to halibut and lingcod. So we used estimates of trophic transfer efficiency to estimate how much of that biomass would move in to the valued finfish. And then we used average values for the commercial species to estimate what that biomass would turn into in terms of halibut and lingcod.
Great. In terms of the change in economic value, a person asked, does that apply to the entire study area, or were you looking at certain numbers of otters or otter colonies?
Yeah, these results were all averaged for the study area that I showed you. So the losses, the transformations in terms of biomass, are cumulative for that whole area in central Vancouver Island, central west coast of Vancouver Island.
Mm-hmm. Okay, and let's see. Ken asks, where do the costs of exclusion and maintenance of exclusion get accounted for?
That is an excellent question that I have not had before. Well, they are not, is the short answer to that question. Yeah, that would depend on, obviously, on how the exclusion was done or the protection was done. I can't do any better than that, so I'll just stop talking.
Okay, that's right. No, it's a dicey issue. This had a question related to potential reintroduction of sea otters into Oregon. The question was, could coastal communities learn to coexist with sea otters? That's kind of a bigger question, but I don't know if you have a sense of, in British Columbia, looking at coexistence issues, what is your sense of the community and willingness to, to figure out how to coexist with sea otters and
So
a whole new world.
this is why so many of us go into natural science instead of social science, because that differs by community, right?
Yeah.
The attitudes differ by community. But of course, they differ by components of that community and individuals within that community, and they change over time. I really pity social scientists, because trying to track this and actually get at people's attitudes is a really, really difficult job. So having said that, it's hard. The sense that I have is that there is perhaps three camps here. There's the conservationists who really don't have much skin in the game, who really want to see rewilding happen, who want to see things restored to how they were, for the betterment of the ecosystem. And that's a perfectly legitimate perspective. Then there are people who benefit economically from the system. And they tend to always, in any context, really prefer the status quo, because they are doing well and they don't want to see the status quo interrupted. And then there are the coastal communities who are much closer to the land, have the most skin in the game, and have watched dramatic changes over the decades or centuries since occupation, since occupation. And there it's mixed. And generally people are coastal communities respect sea otters. They see themselves as having a long relationship with sea otters, and many people welcome their return, but with caveats. And of course, within those communities, there are also people who benefit economically from the status quo, and that's reflected in, that puts them maybe into one of those other camps. So yeah, it's mixed. It's mixed.
And I mean, you sort of touched on it, and maybe you don't want to go there, but how would local management of sea otters work? Has there been discussions in British Columbia about that?
Yeah, there is definitely. We have a project with the Haida up on what used to be called the Queen Charlotte Islands, northern BC, Haida Gwaii. We have a project up there looking at what the communities might do, what the First Nations or tribes might do up there in the face of sea otters returning. And that's a big topic of a conversation now. The one thing that we all agree on is that as sea otters reoccupy an area, any management is best done early rather than late. It'll be much better to help sea otters understand their landscape, because animals do understand their landscapes. It'd be much easier to help them understand their landscapes when they arrive in an area than after they've reached carrying capacity. Right. So that's an important thing that everybody agrees with. There's two ways that there's really two approaches. There's exclude the sea otters or protect the resources. And probably some hybrid approach here would be useful. Historically, when there were tens of thousands of people living on the coast year round, it was much easier to do those things, to protect your resources and to exclude otters. It's a lot harder now, so we expect that there will have to be people around, to do that, to make it more effective. And I can go there. For years, we talked about a lead curtain on the west coast of the island, which because we were finding washed up animals, sea otters, that had actually been shot trying to travel down from Cayucet into the southern part of the range, particularly into the crabbing grounds that are around Ucluelet. So they were physically prevented from expanding their range that way. There is a whole body of literature on something called fearscapes, which relies on animals learning where it's risky for them to be. And so in order to exclude otters, it's likely possible that consistent hazing or disincentivizing them from going into certain areas would be enough. I don't think it necessarily needs to be a lethal activity constantly, because the animals will learn. But that goes back to requiring people there, right? If the hazing, as long as the hazing or the disincentives are present, it'll be fine. But if you leave for 6 months, then the animal's going to learn that the hazing isn't there. So that relies on the community. So perhaps there's things on the protection side that could be taken from traditional practice, like clam gardens and such things, and updated into a modern context with modern technology or something, so that people wouldn't have to be there so much. Clam gardens are a great opportunity for protecting a lot of those resources. And we would look to technology to maybe, I don't know, cover gooey duck beds in a way that they couldn't be dug, perhaps, by otters. And, our study, just to sort of bring this to the last species that I'm thinking about, which is Dungeness crabs, our study ended at 40 meters depth. Many of these species exist below that. So there could just be a need to partition the resource use a little bit differently. Crabbers, instead of fishing in shallower waters, may have to go deeper. So there may need to be gear adjustments for how crab are harvested, because they're still there. They're not functionally or biologically extinct. They're just commercially extinct in the way that they're being fished now.
Right.
So number of ways that could be addressed, I guess.
Right. Very complicated. And I'll add one one last complication. Maybe we'll have our last question here, and we'll start wrapping up. Moving forward, I don't know what things, there are things on the books in terms of looking at more social or cultural costs and benefits, other projects or valuations in the works in British Columbia or even anywhere else you're aware of, maybe up in the Haida area. But
valuations?
Yeah, just looking more at the, you talked a lot about social science, but looking at social and cultural costs and benefits.
So we're getting pretty good at taking things at the ecology side, at least comparatively. Yeah, we're getting pretty good at being able to estimate biological impacts and abundance and distribution of at least some things. How people feel about those is difficult, and there's been a Coastal Voices project that was led by Anne Solomon that I think included both BC and Alaskan tribes to see how people feel about all the resources, really, and relative comparisons of all the resources. Some of that work is also coming out of our work on Haida Gwaii. But it tends to be the thing with social science work. It's very localized as well. That's you have to go to communities, you have to build trust, and then only then will people start sharing information with you. That's changing a little bit because you can use the internet now to take much more broader surveys of people's attitudes, but the quality of your data is going to be poor. I know I'm adding all sorts of caveats to it's a fairly simple question, but people continue to work on this. I don't think it's getting any easier.
Yeah, I think it'll always be complicated, and that's why we're having these types of talks at Sea Otter Awareness Week. So
I think that we're living in such a polarized world now. Things are becoming more and more polarized. It's getting harder and harder to have these conversations. So something like what you're doing here with the Sea Otter Awareness Week and building a big tent for people to come and actually talk about these things is the best way to get there, because the evidence shows that consensus building is key to making these management decisions that make everybody happy. So yeah, the bigger the tent and the more conversation, that's really the solution, not more research.
Right.
In my view.
Yeah. All right. Well, Ed, thanks so much for sharing your work with us today. I think these kinds of socioeconomic valuations are going to be even more and more essential as we try to determine effective plans for with reintroducing sea otters, or like you say, just getting along in the big tent. Thanks to all the attendees for joining us. Heather, do you want to give any last words?
I'm going to do a few last plugs, and I just want to say thank you, Ed, for this presentation. It's been so informative, and kind of as you talked about of these different camps and how important it is for us all to be communicating about this, because it is extremely complex. And you were mentioning different types of exclusion zones and locally, and what would that mean? And there's questions about what would that look like. And so I'm going to put a plug here for the survey again, because if anyone has these specific questions or has what they feel the skin in the game for this is an opportunity to really get your voice heard. All of this data is going to be shared with those in management positions. So, you know, sea otters, like other fish and wildlife populations in the US, are held in public trust. So I actually think that who has the skin in the game is a little bit wider than that. But this means the government is really managing and protecting resources to benefit the public. And so those discussing potential sea otter reintroduction to historical habitats, like some of the areas that we're talking about in Northern California and Oregon, you need to hear from you. Your voices and your opinions matter. We want to hear the tough questions. We want to hear the concerns. And so please take the stakeholder survey. I'm going to add it one last time into the chat. And again, thank you all for joining us today. And this video is going to be, Andy has it recorded, so I'll add it to the Sea Otter Savvy YouTube channel, as well as I believe Defenders will do to theirs, and we'll be sharing it out. If you have further questions on this video, you can actually ask those questions on the YouTube channel underneath that video, and I will be going back. And if we have some ones that are extra difficult, Ed, I might get you to answer them for me, and I'll be able to put them into people there as well. But here's the survey.
All right. Yeah, well, thank you very much, Heather and Annie, and thank you everybody for listening. It was a pleasure to be here. And if anyone, I'm just sort of paging through the chat, and if folks would like to follow up with some of those questions, my contact information was on the last slide, so I'd be happy to hear from anybody who wants to follow up.
Wonderful.
All right, so everybody track down Ed for your questions, and yeah, thanks again, everybody. Have a great rest of your day. Appreciate it.
All right.
Bye, everyone.
Thanks again. Bye-bye.